Hi everyone, today we're going to talk about Venn diagrams and two-way tables. The first one we're going to look at is complement. Now be very mindful that it's not complement like saying something is nice. It's a complement with an E coming from the word complete. So let's say we are rolling a dice and the sample space is 1, 2, 3, 4, 5, 6. Recall that the sample space means everything that can happen. So, and it's represented by this little E symbol that you might want to practice. It looks like a lowercase tiny e followed by a capital C with a little wiggle. So you might want to try that a few times in your books. Anyhow, so if I wanted the event A to be, let's say, odd numbers, so 1, 3, 5, then I could represent this in a Venn diagram like so. Everything that is part of A is inside the circle. The complement of A, or the thing that completes A, would be not 1, 3, 5, the other numbers in the set that we have here. So not 1, 3, 5. It will be whatever I have encircled. It will be 2, 4, 6. So the complement of A would be the even numbers. And we can represent this in the Venn diagram like so. Sometimes you'll see Venn diagram that looks like this. Now, if this is A, then this will be a complement of A with a little dash. Let's look at Venn diagrams more closely. Let's say event A is again 1, 3, 5, and event B is numbers greater than 3. So 3 is not greater than 3, 4, 5, 6 are. So if A is 1, 3, 5 and B are 4, 5, 6, how do we put it inside the Venn diagram? We notice that there's a number in common, which is in both of them, and that's number 5. Now, 1 and 3 are in A, but not B, and 4 and 6 are in B, but not A. There's a number missing, 1, 2, 3, 4, 5, 6. 2 is missing. 2 is not in A or in B. Let's have a look at the next word, intersect. So looking at the diagram before, we noticed that a number happens to be in both A and B. We call this the intersect, and it's represented by that symbol there, intersect. Let's look at the word union. If we look at all the numbers that were A or B, then we say that we're looking at the union, and it's symbolized by this little symbol that looks like a U. So the union of A and B is 1, 3, 5, 6, 4, and 6. All the numbers that are in either A or B. So to summarize these two words, make sure that you remember these two words. Intersect is the overlap, or that symbol there that looks like a little bridge. And I remember it because intersect is like a little lowercase n. And it has to satisfy both conditions. So intersect is the overlap of both of them. So 5 has to be in A and it has to be in B. The word is and for intersect. So if I give you a question, a mathematical question, I say something, 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 and then I'm referring to intersect, not union. Whereas the word union is represented easily by U for union. And it's when it can be any of the conditions. So 1 is part of the union because 1 is in A. 4 is also part of the union because 4 is part of B. 5 is also in the union because it's part of both of them. So it doesn't matter which one it is as long as it's one or the other. So or is a keyword that we'll use whenever we want to refer to something that's part of a union. Now let's consider these two scenarios where we have A intersect B dash and A union B dash, or A intersect the complement of B and A union the complement of B dash. How could I explain it to you so you can totally visualize it? So we're going to have a look at representing A in this Venn diagram here, and we're going to represent B dash in this Venn diagram here by coloring it in. So I'm going to color in A, or as best I can, in yellow, and I'm going to represent B dash, so everything not B, as blue. Now I said previously that the intersection is when they overlap. So let's have a look at what so let's have a look at what A and B dash look like when they overlap. So we can clearly see that our intersect is the green part portion. So A intersect B dash is this section here, whereas the union is coloring everything that has been colored. So remember, when it's union, it's coloring everything that's colored. When it's intersect, it's only coloring what has been overlapped. Let's practice coloring a little bit more. Now you should pause the video and copy this diagram down and see if you can color in correctly. So we have the intersect of A and B. Now the intersect of not A, which means everything outside of A, and B will be this section here. And if you look at these two together, they add up to be B. Now A intersect not B, so or complement B, another way to say it is not B. So everything outside of B and A would be that section there. Not A intersect not B, so the overlap of those two would be the outside. And if you add these two together, you're going to get not B, or complement of B. And if you go downwards, you also realize that if you go downwards, it also adds up to be A. If you add those two together, same with the second column, it will add up to be B. And it doesn't matter which way you go, whether you're adding this way or you're adding that way, you're going to get the whole thing colored. Here's another example. Pause the video if you want to give it a go. Label these as A, B, A intersect B, etc., etc. So you might want to pause the video and give this one a go as well. So A would go here, B would go here, A intersect B goes in here, A intersect not B. So not B would be outside of this circle, and then A would be there. A intersect not B would be here. A not A intersect B, so B is here and not A would be outside of that. So A not A intersect B would be there. And not A intersect not B would be outside. It doesn't matter if you put it up there or if you put it down here. Two-way table. Another way to represent all these things is using a two-way table. Let's have a look at two-way tables. We're going to put A here and A complement there, or not A. B here and not B there. And then what goes in the middle is the intersect. Just like these four images there. So let's look at an example. The Venn diagram below shows two events: D, people that like donuts, and F, people that like fish. So we can put donuts, don't like donuts, fish, don't like fish over there. And now we can put the intersect of F and D in the middle. So the intersect of F and D is 6. The intersect of F and not D, so not D means outside of this circle, and F is inside of this circle, so we have 5. So now we look at not F, so outside of this circle here, but inside D, so that's 10. And we know that not F and not D is the outside number 9. So what is the probability of D intersect F? So for the probability, we have to count the total. So what is the total? 10 plus 6 plus 5 is 21, plus 9 is 30. So we have a total of 30. So D intersect F is 6. So the probability is 6 over 30. And you can simplify this by dividing by 2. Oh, one more, dividing by 3 again. 1/5. So divide by 6. What is the probability of the complement of D? So adding these two together gives me the complement, which is 14 over the total of 30, or in other words, 7 over 15. What is the probability of D intersect F dash? So this value here, 10 over 30, which is 1 over 3. Now, be very careful now because this is now union. Let me erase this, make it a little bit neater. So union. What is D union F? So everything inside these two circles. So 21, and the probability would be over 30. Or in other words, 7 over 10. What's the probability of D dash union F? So F would be in here, and D dash would be the outside. So everything that's union means colored in. So 6, 5, and 9. So that is 20 over 30, or 2 over 3. So just remember that union means any of them colored, and intersect is their overlap. Let's look at example 2. The Venn diagram below shows what some people had for breakfast. C is the event that they had cereal, and T is the event that had tea. So C for cereal, C not C, T not T. Now we fill it in. So intersect of C and T is 35. I'm going to do the outside this time. 4 goes here because we know that. So that's in the middle, that's the outside. Now T not C. So inside T is 42. C not T. So inside C goes over this side. Okay. Might want to replay that and memorize that. So what is the probability of not C? So not C means both of these guys. So that's 42 plus 4 is 46 over, we have to count the total. So 19 plus 35 plus 42 plus 4. So let's do that. 19 plus 30, oops. Okay, let's do that. 19 plus 35 plus 42, oops, plus 4. 100 exactly. So the probability is 46 over 100, or you can write it as a decimal point as 0.46. What is probability of C intersect not T? So C intersect not T is 19 over the total, which is 100. And then not C not T is our 4. 4 over 100, which is 0.04. Let's try another example. There are 25 students in our class. 10 of them are wearing dresses today. So let's do D for dresses, not D. So 10 of them are wearing dresses. So we have D. Now the total, we'll always leave it outside because we don't know how many are in the intersect and how many are dresses but not the other thing. 12 of them have watched Endgame. So we're going to call this E. E, not E. 12 of them have watched Endgame. So write 12 over here. And 5 of them were wearing dresses and have watched the movie. So 5 of them are in the intersect. Write a two-way table. So there's 25 students, and in total. Now 10 are in D. If there's 5 there, then there's 5 left over because you do 10 minus 5 is 5. Now 12 are in E, so there's already 5 in that middle spot. So there's 7, because 5 plus 7 is 12 left over. So we're done with those numbers. Now that we have these three numbers, 5 plus 5 plus 7, that's 17. So they are missing, how many students are missing? They're missing 8 students. So the other 8 students go in here. Double check, 5 plus 5 plus 7 plus 8 is 25. So we're good to go. Now we can fill this up. So 8 goes there. E intersect not D is 7, and D not E is 5. So now we can answer the question. Write a two-way table. Done. Draw a Venn diagram filling the spaces. Done. What is the probability of picking a student and talking to them about endgames and not ruining it for them? So if I don't want to ruin the movie for them, that means they haven't seen it. So not E. So 5 plus 8, which is 13 out of the 25 students. What is E union D? So everything that is in E and in D, that is 17. Now take note that it's not the probabilities this time, we're just asking what is that value. What is E intersect D? So the number that is overlapping, that is 5. What is E dash or not E intersect D? That's also 5. We're talking about that 5 over there this time. Where would you fit in that diagram? Well, depends on whether you've watched Endgames or not. Here's another example for you. You can pause and check the answers coming up. That's it from me today. Bye.